Number 6 requires us to look at the graph. All right, so we have an absolute value, so we know that this guy is V-shaped. All right, so what I'm going to do is I'm actually going to get a sheet of graph paper here, and I'm going to sketch a quick graph. Okay, and we're going to kind of just, whoa, man, okay, I can't look at the screen. I got to look down when I'm doing this. That was really bad. Anyways, this guy right here is an absolute value, V-shaped, and we don't have a value in front here, so it looks like it'll just be a slope of 1 going this way. So maybe it's better to go like 1 and then -1. Okay, so this guy needs to go to the left 4. So let's go left 4. And this is just a sketch, so I'm just going to place this out to the left 4. And then I'm going to go down 8. Okay, so I'm going to go down 8. All right, so this means that my vertex for the V, okay, this guy's the vertex. Okay, that's the vertex. All right, that vertex is going to look like this. All right, but we need to reflect this across the x-axis. So that means this guy has to be up here and he has to be pointing down. That is a reflection on the x-axis. So what this means then is I have to go through here, these guys right here, and figure out which one of these represents this. Now, if I'm reflected over the x-axis, notice how I'm still to the left 4. All right, I'm still to the left 4, and I'm not down 8, but I'm up 8. And I'm also pointing down. The only one of these that actually shows that, this guy means move to the right. Okay, if I would have moved to the right, he would not have been reflected on the x-axis. He would have been reflected on the y-axis, and he would have had to gone up because this right here says +8. Now 4 minus x, I don't know what that looks like. I'd have to use a graphing calculator for that. So this guy right here is the one that fits the bill right here. So our answer is D. All right, 7. We're also going to use the graphing paper for this one as well. Dana is filling a 1.5 gallon watering can at a rate of 0.75 gallons per minute. What is the domain of the function? Okay, now you can see here that it looks like x for each one of these instances is starting at 0, and then it'll go all the way to the end of a particular limit. Now, if, let's see, she's filling a 1.5 gallon watering can at a rate of that much per minute. What is the domain? So what we've got to do is we have to figure out how long is it going to take to fill up the 1.5 gallons. Okay, so in your calculator, what you would do is you would take the 1.5, okay, and you would divide it, or we could just put divide by 0.75. How many minutes is it going to take to fill this 1.5 gallon jug? Now, let's not put the division sign like that. This is more appropriate for algebra. When we execute this, we will see that it actually will take 2 minutes. Now, one of the other things that you can do too is just think that 1 minute you would have 0.75 filled up. Then you would just add another 0.75, and you would keep adding that 0.75, and then you would count how many minutes you actually were filling the jug. Now, it just so happens that right here is where the 1.5 stops, and it's actually full. But maybe, for example, on your test, these numbers are going to change. And so if you know the rate, you know how much quantity is changing per minute. And then you're going to want to count those up. Now, in this case, we can see it only takes 2 minutes. Okay, so now it's got to be either B or C. Okay, but here we have to ask. This says that 0 is allowed. This says that 0 is not allowed. So you just have to ask yourself, does it make sense that I was allowed to have a 1.5 gallon watering can that's empty? Was there no water in it, or was there always something? No, of course. All right, of course. And if you fill up, and if you, I'm sorry, 0 minutes, like, no. sorry, it's not filling it up, it's time. Okay, so time, did we start at 0, or did we just like skip a millisecond and then start on the other side of 0? Okay, so I'm sorry, this is the domain, so it's about time. So we went from 0 to 2 minutes, and we stopped at exactly 2 minutes. We were allowed to go to 2 minutes. All right, so watch out for that. You know, it's kind of a big deal to say whether or not you can equal something or not. So the answer to that is B. All right, where are we at on time? 5 minutes. I'm going to go ahead and do one more. So for this video. So number 8. Number 8 is, I'm going to go ahead and just move this over here. Over what interval is negative absolute value of x minus 2 increasing? So let's sketch a graph of this guy. All right, he is, he's pointing downward. Okay, so we know that he'll look like this. Okay, and he's going to move to the right 2. All right, negative 2 is on the inside of the parentheses. So he's going to move over to the right 2. That puts the vertex right here. All right, and he will have slope like this and slope like this. Messed up, slipping. All right, so where is he increasing? Well, it's this piece. Now the whole thing is negative. All right, that's clear, except for this point right there where it's neutral. The whole graph is actually negative, but that's not what it's asking. It's asking where is it increasing, and so we're looking for when this guy is actually going upwards. And so it looks like we're going from negative infinity, and then we go all the way to 2, and then he goes neutral for a moment and then starts to decrease. All right, so the only one that actually fits the bill here is actually B. All right. Okay, actually 9 is going to be quick just because yeah, this is a quick one. So here's a parent function is changed to a quadratic, so it's not a V shape, it's a U shape. Okay, but that doesn't matter. The same thing applies. If the value is on the inside of the parentheses and it's minus 5, this means that I'm going to the right 5 units. You're not actually doing much math at all. In the next unit, we're going to work with the vertex form a lot, but here we can just say that it moves to the right 5. Okay, she moves to the right 5. This tells us that she's going to go down 4. So going down 4 can't be those two. Left, nope. Right, so it's got to be D. All right, we'll stop there.